My course project was on the ice cover on Lake Huron. My research question was, are ice cover levels lowering on Lake Huron over the years? I found statistical research recording the percentage of ice cover on Lake Huron during its most frozen days of each year between 1973 and 2020. I then looked up the long-term average percentage of ice cover on all the Great Lakes, including Lake Huron, which was 54%, and compared those results. I found the following data recording the percentage of ice cover on Lake Huron during its most frozen day from the years 1978 to 2020. I then located the long-term ice cover level percentage on the Great Lakes according to National Geographic, and that percentage was 54%. This will stand as my proposed population mean. From my research data, the sample size is 48, the mean is 64.61, the median is 64.9, with a standard deviation of 23.52. The minimum is 23.06. The first quartile is 43.73%, the third quartile is 85.68%, and the maximum is 98.2%. This histogram shows that the data is well spread, without any extreme outliers. It also shows that in the majority of years, the ice cover was less than or equal to 46.06%. I used a significance level of 95%. This means that I could rely on my result being accurate 95% with a significance, or alpha, of 0.05. To test this, my null hypothesis was the average ice cover percentage on Lake Huron during its most frozen day is greater than or equal to 54%. My alternative hypothesis was the average ice cover percentage on Lake Huron during its most frozen day is less than 54%. This was a one-tailed, left-tailed test. The test statistic was -3.1236, and the p-value was 0.0015. The alpha is 0.05, with a t-critical of 2.012. In conclusion, p is less than alpha, and the t calculated is to the left of the t-critical. So we will reject the null hypothesis. There is enough evidence to support the alternative hypothesis.